Hello viewers and my dear students. Welcome to session 2 on projection of planes demo. And we have started with a demo on triangular lamina in the previous session and that will be completed in this session. Okay. This demo, as you are aware, we are doing using Solid Edge software. Okay. Now, in the previous session, we had come till this. That means a triangular lamina of size 25 has an edge on HP with surface inclined at 60 degrees to HP. Okay, this you should, as soon as you look at this, you should be in a position to tell. Here it is a true surface and you've got the front view here. Okay, now this is the imaginary median what you are seeing. This is the imaginary, since it is parallel to VP, front view length is actually median length only. If you lift this about this corner up, this C if you up, it will be edge on HP. If you lift this B dash A dash up, it will be corner on HP. That's why this triangular lamina here afterwards you can call it as edge and corner position of triangular lamina. That means you can make both edge on HP or corner on HP on one single position. Now if you see here, I have drawn the top view, front view here. Okay. Now I have tilted about edge AB. Okay. Such that the surface is inclined or median inclined at 60 degrees to HP. And once you tilt it, when you are looking from the top, see here AC and BC here they were in true length. Now AC and BC what you have here, they would have reduced in length. That is why AC and BC would have reduced. But since AB is on HP, AB is still in true length. Okay, AB is still in true length. Now, this is the front view and top view of this triangular lamina when edge on HP, surface is inclined at 60 degrees to HP. Now, I have told you in different sessions of projection of plane surfaces, keeping this inclination constant, please understand, that is surface inclination to HP 60 degree constant. If you rotate this lamina, that is if you rotate this lamina about AB, you keep rotating. Whatever you do, AB if you rotate it, but the condition is 60 degrees to HP should be constant. As long as inclination to HP is constant, and if you rotate the lamina, the top view will remain same. Okay, this you know. But in this problem, what they've said is edge on HP inclined at 60 degrees to VP, they've said. That means edge on HP is AB. This edge AB should be inclined at 60 degrees to VP. That is the problem they are given. Okay, now what you do now, this you have a move command here. Move you take, copy this entire thing. You see that this copy is there. Move and copy both should be there. Okay. Then with any point as the reference, you move it somewhere here. You move it somewhere here, anywhere. Okay. You put escape. Okay. Now this is moved here. Moved and copied. Now you have a rotate command also. Rotate. When you rotate it, no, you don't need this copy. But I want to rotate. I want to rotate this AB in such a way that it is inclined at 60 degrees to VP. That is why what I'll do, I'll select the entire thing and I'll fix this point. I'll move this point here. Now rotation angle 0. If I do this at 30 degree, okay, this remaining will be 60 degree. Okay, that is why now it is here. Rotation angle is 0 here. As you see here, rotation angle is in this position, it is 0. Rotation angle is 0. I'll make it, you see here, I'll do this at 30. Okay, do this at 30. Okay, so that this I rotated from vertical, I rotated to 30. But this AB will be inclined at 60 degrees. Okay, anyway, you just see. See here, when you want to extend, no, this parallel line you take. Parallel line is the reference if you take. Okay, that means it will be a continuous line. Okay, that means this line and the AB will be collinear. Okay, in that way you can do. Okay, this extra thing and all that, you delete it off, and this portion you make it light. Okay, you make it light, and the edge on HP is inclined at 60 degrees to VP, no? Then you see that, see here, angle, that is small dimension angle also you take. With reference to this, it is 60 degrees to VP, correct? No? Edge on HP is inclined at 60 degrees to VP. Okay, now in this position, you have to get the front view. That means you see here, this is change of position method. I have told you in different sessions. Now I am doing a practical demo using solid edge. You understand? I am doing slowly. Now this you understand. Here it was edge on HP inclined at 60 degrees to HP. Edge on HP. Surface inclined or median inclined at 60 degrees to HP. Now in this position you should know 60 degrees to HP, surface inclined to 60 degrees to HP is maintained constant. But edge on HP here was perpendicular to VP. Now edge on HP, here it was perpendicular, now it is inclined at 60 degrees to VP. If they say 30 degrees, you make it 30 degrees. If they say 50, make it 50. But right now, as soon as you look at this, you should know, coordinating all that, edge on HP, because B dash A dash on X1, surface inclined at 60 degrees, correct? 60 degrees to HP. That's why you got this. Now the same top view, the second stage top view is same as third stage top view, because as long as inclination to HP is constant, the top view remains same. That's why I take the same top view and repeat here and rotate in such a way that AB is inclined at 60 degrees to VP. That means this clearly says edge on HP is inclined at 60 degrees to VP and surface is inclined at 60 degrees to HP. In this complex position, when you look from the front, how it appears in the front view has to be drawn. That is the front view and top view. That is what you are expected to do. It is called projections. Okay. Now, see carefully. Take the projectors. Okay, once you do this, as you are aware, carefully you get that is adjust to this. This is C, no? This is C. On this you should get C dash. Okay. This is B. This is B. On this you should get B dash. This is A. This is A. On this you should get A dash. Okay. And you can name this also. Okay. C dash, B dash, A dash. Okay. Now, as you know here, this is B. Carefully you see, this is B. Okay. This is A. This is C. This is C. Okay. Now, if you want to cut short the extra things and all that, you can do this. Okay. Now, you can enlarge it also, because if you enlarge it, you will have a clear idea. You zoom this. Okay. If you zoom this and using line command, okay, line, and directly take 0.5 thickness and take it here from this point to this point to the end of this, and to end of this you take. This will be then fit. Okay. In that way, if you fit, okay, if you fit this, you have got this. And this is XY VP HP. Now you see a triangular lamina has an edge on HP with surface inclined at 60 degrees to HP. Keeping 60 degrees constant, I rotated the lamina here about AB such that AB is inclined at 60 degrees to VP. That means the lamina has been brought to this complex position. In this position, how it appears in the front view, how it appears in the top view has to be drawn. This is how I have drawn. Okay, that means get the points, get carefully this. In that way, you are able to complete the problem without any difficulty. See here, these things I have told you earlier. Now you see these things and all that. You know very well the problem is over at this stage. The problem is over. You directly take the printout, file, print. Okay, you just see whatever is the printer and all that. They'll help you. Okay, in the settings, no, this is paper length and design length should be same. You see that paper length and design length, if it is same, no, then 40 minutes 40, 25 minutes 25 only it will be, because sometimes it will take the scale. You see that this paper length and design length are same. Otherwise, if it is 0.9, this 25 will not be 25. 25 into 0.9 it will be reduced. Okay. Now in that way, you put the active sheet and take the printout. Okay, you say it will get the printout of the active sheet. I'll say, because I created so many sheets, can you understand? Sheet 1, sheet 2, sheet 3, sheet 4, sheet 5 and all that. If I give all sheets will be printed. Now active sheet means this is the active sheet, only that sheet will be printed. Okay, you just say okay. In that way it will get over. Now as you are aware, see here, these things I have told you. Now edge on HP means B dash A dash. Corner on HP means you would have seen, you would have lifted B dash A dash up so that C dash would have been on XY line. Then corner and HP with surface inclined and median inclined at some degrees to HP and all that, which I have told you in the last session, that is in projection of plane session, you recollect. Now it can be edge on HP or corner on HP. Be careful. Edge on HP, that's why B dash A dash on XY line. If it is corner on HP, see that C dash on XY line. In that way you draw front view. First stage front view and second stage front view should be same. And since inclination to HP is constant and you are rotating with respect to AB, second stage top view and third stage top view will be same, because inclination to HP remains same. Okay, when inclination to HP is same, top view will remain same, and even if you rotate it, the top view will always remain same, only position will change. The position will go to some complex position such that AB edge on HP is inclined at 60 degrees to VP. Okay, in that way you have got this. I have told you carefully, please imagine, I was telling you, in case right now the problem is over, you have stopped doing this problem is over, you take the printout, you will get full marks. There is absolutely no difficulty. I just want you to revise some of the things what I have told you in earlier sessions. In case now surface is inclined at 60 degrees to HP. Okay, edge on HP parallel to VP means what would have done is I would have copied, that is move, copy, paste and rotate in such a way that AP is parallel to XY line. Is it okay? When AP is parallel to XY line, edge on HP is also parallel to VP. Okay, in that way, if they say edge on HP parallel to VP, make AB parallel to XY line. If they say edge on HP also on VP, put AB on XY line. That is, move, copy and put AB on XY line, get the front view. If they say edge on HP, opposite corner in VP, put C on XY line. Okay, such that AB is parallel to XY line. Okay, in that way, you can do so many changes and all that, and depending on the problem given. Okay, now this will come to the end of session 2 on projection of plane surfaces demo. This demo will continue. We'll have a demo on a square lamina. We'll have a demo on pentagonal lamina, hexagonal lamina and all that. Please keep watching. Thank you very much for watching. Thank you friends. Thank you.